Hey, welcome back to Mama Physics! This is part 2 of 6.3, Similar Polygons, in which this video we're just going to go through more examples. And what I will recommend is I will prompt you to pause the video throughout the question in case you want to do the rest yourself. Because example 3 and 4, if you understood what we did in the previous video, you should be able to do this almost pretty much by yourself, with some guidance maybe. So that is why I am suggesting that. So let's get down to this video. Let's keep this short. Okay, we have two polygons here, and we want to identify the similar sides from both diagrams. We need to first identify what HG is. So let's label this on this diagram. We want to know what this side is. And NP, we want to know what NP is. So we want to know this side. Ah, that's an ugly drawing. Okay. Because the polygon doesn't give us a lot of information, so we kind of have to work our way out to figure out what we need to do. There are some sidelines given. So for example, AB is given to us as 5.4 meters. FG is given to us as 27 meters. IJ is, on the other polygon, is 8.1 meters, and the bottom side is 32.4 meters. Maybe what I'll do is, here's the prompt. If you want to completely try this question independently, here's a good chance to pause the video. Now, if you want to get some guidance, let's take a look at the two polygons. We notice that to find MP, we have FG for the similar polygon, but we don't know how much we need to scale it up by. Same thing for QP and HG. We don't know how much we need to scale QP down in order to get HG. So we need to know the scale factor. To find the scale factor, or the ratio of the two side lengths of corresponding side lengths on these similar polygons, we need to find a side length that are similar, or that is similar. So that's AB here, and this other one, which is IJ. Okay, so we have these two side lengths. If we can use those side lengths to find out the scale factor, we can use that to figure out HG as well as NP. Okay, so that's the first step. So maybe let's do that together, and then we will move forward. Okay, let's take a look here. Okay, so here we have to, I'll just do it up here for the scale factor. So then here's you have to be careful of. You need to be careful of which one is the original, which one is the copy. You might want to scale up, or you might want to scale down depending on which polygon you're talking about. For example, if you want NP, this is a scale up from 27 meters. If you want HG, this is a scale down from 32.4 meters. So the scale factor that I'm going to use may not work depending on which side it is. But all I have to do is flip the two numbers. So here, if I have an enlargement, if I'm trying to enlarge, this will be 8.1 meters divided by 5.4 meters. So this is assuming that whatever I'm trying to figure out, I am trying to enlarge it. I'm trying to figure out one NP, for example. That's an enlargement. So that one is going to give me 8.1 divided by 5.4, 1.5. Hey, nice numbers. But what happens if I want to reduce? What if I want a reduction? So I want to find the side length of the smaller polygon. Then I need to make sure the smaller polygon side is on top. 5.4 over 8.1. And that's going to give me 1 over 5. Is 2 over 3, I think. But we can always check. 8.1 is 0.66666. 0.66666. Or this is 2 over 3 in fraction form. There you go. That's in fraction form. Okay. So now we figure out the scale factor. That's important because we need to know something before we move on. Then the next task is to figure out what HJ is and what NP is. So this is also a good time to pause the video if you want to just do the rest of the question yourself, now that you know the scale factor. Okay, now I will do the rest of this question then. So feel free to pause if you got a gist of it and just want to try B. A, calculate the length of HG. Find corresponding lengths. Hey, they did a question for you, and in fact, they even wrote the scale factor for us. Notice what I did is I did a ratio. I did a scale factor, so in which you just need to multiply by my scale factor to enlarge it. But how they structure in this question is slightly different. They do two ratios being equal to one another. To be honest, it doesn't matter which way you use, as long as once you fully understand how all of this works, you should be able to freely move freely between the different kinds of methods. So if I want to show you this method, that's fine as well. We can do it. Okay, so here we have, I'll explain why they set it up this way. We know that AB to IJ, these are similar. They did the smaller one, the smaller polygon, to the bigger polygon. So if we want to find HJ, which is this one down here, which I'll use purple, okay, then we also need to make sure they match in terms of what's on top, what's on the bottom. If the smaller one's on top, let's label this 1 and let's label this 2. I want one first polygon over the second polygon, and I want that to be the same on the other side of my ratio, in which my smaller side length is taken over the longer side length, Q, 32.4 meters. So the ratio remains the same. So then all we have to do now is just to solve for HG. That just requires us to multiply both sides of the equation by 32.4. And if I do that, I get 32.4 here, it cancels out. I get 5.4 times 8.1 times 32.5, and that's going to be, wait 1 second, I think I did 21.6. And this is going to be in centimeters, meters, because everything else is in meters. Now notice this other thing that I did up here. If you used a scale factor method, then this is a reduction from QP. So all you have to do is to multiply QP by this scale down factor of 0.6 repeated to give you your 21.6. And you can try that. 32.4 times 0.6666, which is just 2 over 3. That's also going to give you 21.6 meters as well. Okay, so both methods work. They're not really methods, it's just same math. Anyways, let's do the next one. Okay, so next up we want NP and corresponding to FG. So notice that in using the way that they show us here, we need to make sure that the side lengths correspond to the right part of the polygon. IJ is the big guy, so that's 2 divided by the smaller side length here. IJ is divided by the smaller one. So NP is the larger side, is also on top, on the other side of the equation. FG is on the bottom, just like how the ratio is set up. So if I put in some numbers, I want to find NP. FG is 27. I got lazy here. IJ is 8.1 and 5.4 on the bottom. So I got a little bit lazy. If I want to find NP, I multiply both sides by 27. Cancels out, so I get NP is 8.1 divided by 5.4 times 27. That's 40.5, don't forget the units, in meters. If you did it my way, which we just use the enlargement ratio, the scale factor, then we just take the side length, which is 27, we multiply by the scale factor. Because it's larger, it's going to be a number greater than 1. 27 times 1.5 is going to give you 40.5 meters. Okay, so that is if you use the scale factor method. Okay, that was it. All right, moving on to the next example. Hey, this is not too bad. What are we trying to do here? The two polygons are similar. Find the missing angles and the lengths. So we just, okay, well, the first few should be relatively easy. And then y, here's x, here is y, z's down here. So you want to figure out those missing sides and angles. Now is a good time to pause the video for you to try this question fully. All right, now my turn to go over it. I will go over the whole thing, so no pausing in between anymore. Starting with angle A. Angle A is given to us. It has a symbol there. It's 90 degrees. Okay, that's nice and easy. What about B? Well, we know that B must be the same angle as F since we are told that the polygons are similar. This must be 60 degrees. As for angle C, where's angle C? Right here. And if B and F are the same, that means C and G must be the same, which is 120 degrees. Angle H, well, since we know this is 90, D is told us, we are told it is 90, H must also be 90 degrees. Bam. Okay, so now we can use different side lengths to figure out how much they should scale up by. I am going to do it in two ways. I'm going to use the scale factor method to figure out what the scale factor is if you scale up versus scale down. And I will also do it the way that the notes have shown you as well. So both ways. First, I'm going to figure out the scale factor. So notice that I'll call this polygon 1, I'll call this polygon 2. And notice if we go from 1 to 2, it's a scale down. It's a reduction. So I'm just going to go with reduce here. So how do we figure out is a reduction by what scale factor? We have this side length here, which are similar. So it's from 4 to 3. So to reduce it, I gotta put 3 on top and then 4 on the bottom. It doesn't tell me exactly what the units are, and so I'll just leave it like that. This is going to be 0.75 or 3 over 4 works as well. If I have an enlargement, which is going from polygon number 2 to polygon number 1, I get the opposite. I have the larger polygon on top, which is the 4, and the smaller one on the bottom. This is going to give me 1.333 repeated, in which the fraction works a little bit better. So that's if you want to use a scale factor method. But the textbook, or not the textbook, the notes will probably show you something else. So I'll show you both ways. To figure out x, this side here, let me use green. Okay, so to find x over here, we find the corresponding side length, which is 40. We also know that side lengths 4 and 3 are similar. So then to figure out x, we just need to work out two equal ratios. So we know that we want x on top, hey? Yeah. So if we want x on top, we figure out 40. 40 is on the bottom because this is the ratio. X to 40 should be the same as, and then this is the same thing. You got to make sure the order of the polygons is the same. So 1 to 2, x to 40, is the same as 4 to 3 for the other side length. So then now we just solve for x. Okay? Solve for x. Notice I try to put x on top, so it's easier to do the math. We get x is equal to 4 over 3 times 40. And you might notice that, hey, that's just scale factor multiplied by the side. You are totally correct. The math is totally the same. Okay, so I'm going to keep that as repeated. There is no unit, so I leave it as that. 53.33333 repeated. And if you might notice that this is a scale up, this is an enlargement, I just have to multiply 40 by my enlargement ratio factor, scale factor, which is 1.333. Then you got it. Okay, next one. I am going to use purple for this one. Y is over here, this diagonal line, which corresponds to 32. I am also using this other method. I'm going to use y on top because it's always easier to have a variable on top. Y over the similar side, which is 32, is going to be equal to another ratio, which is going to be 4 over 3 to keep the ratio the same. The ratio of 1 to 2. So let's solve for y, which just requires us to multiply 32 to both sides of the equation. We get y is equal to 4 divided by 3 times 32. And you might notice that that is exactly taking the enlargement ratio, the scale factor for enlargement multiplied by 32 to get the longer side on the similar polygon. Last but not least, we're going to do z is this guy here, but then this is a scale down from side 7. So in order to use the ratio, I'm going to do the same thing. I want a z to be on top, and then it's going to be over the similar side, which is 7. And then I'm going to use the similar side length that I know of, but this time, since I'm doing small to big, I need to do the same ratio for the other side. 3 is smaller, 4 is bigger, so 3 to 4. And then to solve for a z, I need to multiply the 7 up over here. And then this is going to give me 3 over 4 times 7, 5.25. And then you might also notice that 5.25 is exactly, I just have to take 7 multiplied by my reduction factor. That's going to give me that as well. Same thing, okay? Okay, so that is it for this lesson. Notice once you understand the concept of scaling, there is no prescribed method for you to figure out similar sides. Also, just a big recap again, for similar polygons, you must have all the angles, corresponding angles must be the same. All the corresponding side lengths must also be proportional. They don't need to be the same, but they must be proportional. That's how you have a similar polygon. You must fulfill these 2 factors, 2 conditions, otherwise they are not similar polygons. So I thank you for watching. Good luck with your practice. See you next time on Fan Mama Physics, signing out.